Hi, I'm James, and in this talk I'm going to introduce our work, which gives a denotational account of sequential composition. Now, I know what you're thinking. Wasn't that done in the 70s? Well, yes, but the context here is different. We're going to consider sequential composition in an optimized language with shared memory concurrency, like C, Java, or JavaScript running on modern processors. One way to understand the meaning of something is to look at which things are equated and which things aren't. Let's start by looking at two programs that are clearly different. The program on the left loads X into a register and then stores the value of that register into Y. The program on the right performs the same operations, but in the reverse order. Therefore, Y gets the prior value of the register before performing the load. So these programs are clearly different, and they can be distinguished by a sequential context that loads Y after the program finishes. If instead the store takes a constant, then the order of the operations isn't observable, at least not sequentially, and the programs would become equated. But in a concurrent context, we might have another thread which could be interleaved between the two statements of the program. And in this case, we can distinguish them. Here we have a thread that copies Y into X. And at the end, on the left, we'll have that X holds the initial value of the register, whereas on the right, it's going to contain the constant 1. And so these programs are typically going to be distinguished in a concurrent context. Or at least that's the story we would have told in the early 90s. But in this program, the loads and stores are independent, and therefore modern hardware and compilers might just reorder them. And in that case, we end up expecting these to be equivalent. Now, equating these programs creates some anomalies, to say the least, which Marino et al. Summarize as the horror. The problem is bad enough that when the protagonist of their fable asks, what is the semantics of this weaker semicolon? What does it guarantee? The answer is simply, don't know. And this is exactly the open problem that we've attempted to solve. Our solution builds on two bodies of existing work. The first is the calculus of predicate transformers from Dijkstra. A predicate transformer is a function that maps each postcondition into the weakest precondition that's needed to satisfy the property. The second ingredient is a model of concurrent computation using partially ordered multisets, or Pomsets, where events represent stores and loads, and order is imposed either by the sequential semantics or by the requirement that loads be fulfilled by matching stores, or the requirement that blockers stay out of the way one way or the other. We put these together by modeling sequential composition using families of predicate transformers. Transformers are indexed by sets of events. This allows us to compute semantic dependencies in a concurrent model. For example, in the program here, the second thread has a genuine semantic dependency. But the apparent dependency in the first thread is false. Y is going to be set to 1 regardless of the value of X. Let's walk through this example, starting with the second thread. When combining the two subprograms here with a semicolon, we're going to choose the predicate transformer from the left based on the order into the event on the right. In this case, we put an order into the store, and therefore we choose the appropriate transformer, which weakens the precondition. In the first thread of the example, we can omit the order, but in this case, we're obliged to take the identity transformer. That's sufficient here, though, because the precondition is already a tautology. There's further examples, which I don't have time to go through. Our paper is the first to give an account of sequential composition in an optimized concurrent language. And the surprising thing is that concurrency is actually the easy part. It's sequentiality that's hard. There's of course lots of details here, which I don't have time to go into. I hope to be able to discuss them when I see you in Philadelphia.